For this question, we want to know for what values of x does the function obtain a relative minimum. Find the relative minimum value. For what value or values of x does the function obtain a relative maximum? And we want to find that relative maximum value. So in our book, the way that a relative minimum is defined is noticing a change from decreasing to increasing. So if we look at our graph and find a change from decreasing to increasing, that's going to create a minimum value. And in our book, the definition of relative maximum is when we have a change from increasing to decreasing. So a change from increasing to decreasing is going to create that relative maximum. So first we want to analyze the graph for increasing and decreasing, and then we'll see if there are any changes. And if we notice changes, then we have a relative minimum or maximum value. So I'm going to trace the graph going from left to right. So this point here is the farthest left, this ordered pair -12, -11. It's the farthest left. And I'll start tracing the graph, and as I'm tracing the graph, I notice that the y values are increasing. So this portion of the graph is increasing. And when we get to -8, 5, we can now see that the graph is decreasing. And then we get to this point here, -2, -4, and it's now increasing, and it stops at 1, -1. So we can see that this section of the graph from -12, -11 to -8, 5 is increasing. And then this section from -8, 5 to -2, -4 is decreasing. And the section from -2, -4 to 1, -1 is increasing. So we do have a change right here from decreasing to increasing, and it's at the ordered pair -2, -4. So that point is a relative minimum point. Now these two parts are asking about a relative minimum. So pay close attention here. The first part, part A, says what values of x? What values of x? So for part A, we're going to answer -2, the x coordinate. For what values of x does the function obtain a relative minimum? And then part B says find the relative minimum value. The minimum value is the y part, so that's -4. For parts C and D, we're looking for relative maximum, and we can see here is a change from increasing to decreasing at this point, -8, 5. And in part C, it's asking for what values of x. So that would be the x coordinate of -8. And for part D, find the relative maximum value. That's the y value. The maximum value is 5. On this question, we're given a graph, and we want to find the relative extrema. Specifically, the directions say, for what values of x does f obtain a relative minimum, and what are these relative minima? So looking at this graph, so we're starting with relative minimum. And we have a definition of relative minimum, and the definition says that we'll need to see a change in the function from decreasing to increasing. So it would be really helpful for us to identify where the relative extrema are if we identify the intervals of increasing and decreasing on this graph. So I'll do that with two different colors. So I'm going to start tracing the graph from left to right, and along this section right here we can see that the y values are increasing. And then we change to decreasing, and then it changes to increasing again. So I'm highlighting the increasing sections in yellow. And then let's get a new color. And we said it's decreasing along this section and decreasing along this section. We do have one interval where this function is constant, and that is here. The y values are unchanged along that section. So to find any relative minimums, we're looking for a change from decreasing to increasing. And you can see right here, to the left of this point, the graph is decreasing, and to the right, it is increasing. You can also identify it by the fact that we have a little dip in the graph. I like to call it a valley, and this will be a relative minimum. So that ordered pair is 0, -5. So we can say that this function has a relative minimum at, let me erase that, a relative minimum of -5, that's the y value, and it occurs at x equals 0. So this function has a relative minimum of -5 at x equals 0. And then we want to find relative maximum. And a relative maximum is going to occur when you have a change from increasing to decreasing. So you can see right here on the left of this point, the y values are increasing, and to the right of that point, they are decreasing. So that creates a relative maximum at this ordered pair. And it also happens right here. To the left of that point, the graph is increasing, and to the right, it is decreasing. So at that point, 9, 2, we have a relative max. So this function has two relative maximums. So we have a relative max of that's a positive 3 at x equals -4. And we also have a relative max of 2 at x equals 9. Determine whether the function is even, odd, or neither. Sorry, we can't see that, can we? Determine whether the function is even, odd, or neither even nor odd. And we're given this picture of a graph. So on the right here, I have the definition of an even function and the definition of an odd function. A function is even if for every x in the domain, f of x is equal to -f of x. So this is a symbolic way of saying the definition, but our question involves a graph. So we're going to move on to the second part of the definition. The graph of an even function is symmetric about the y-axis. So that's what we're going to use to determine whether this particular function is an even function. And then we have something similar in our definition of an odd function. A function f is odd if for every x in the domain, negative f of x is equal to f of negative x. And we're going to use this portion, which involves the graph. The graph of an odd function is symmetric about the origin. So that's what we have to pay attention to. Is this particular graph symmetric about the y-axis, or is this graph symmetric about the origin? And then we'll be able to say that it's either even or odd. And if it doesn't fit into those categories, then we say neither. So being symmetric about the y-axis, our y-axis is this vertical axis here. And being symmetric means that there would be like a mirror image over the y-axis. And we can see that on this particular picture that if we were to mirror over the y-axis, the mirror would look something like this. And that doesn't match up with any portion of the graph. So we can very clearly say that it is not even because we don't see that y-axis symmetry. So then we want to know if it has symmetry about the origin. Now the origin is this point here where the x-axis and y-axis cross each other. That is the origin, and that is the ordered pair 0, 0. So in order to have origin symmetry, you would have a mirror image over the origin. And sometimes people have a little bit of trouble visualizing this, so I like to think of it as two mirrors. You can mirror once over the x-axis and once over the y-axis. So if I were to take this piece of the graph and mirror it over x, then I would get this portion and this portion mirroring it. So we flip it over the x-axis, and then we're going to flip it over the y-axis, and we get a mirror on the other side. One other thing that you could be looking for with origin symmetry is these opposite quadrants. So you can see, and this is quadrant 2, and this is quadrant 4. Those are where we have the graph matching up with each other, mirroring each other. So this function is an odd function, and it has origin symmetry. Just one last thing to mention here is that we don't use the labels of even and odd on graphs that are not functions. So we want to double check that this is a function by doing that vertical line test. And every vertical line that I draw is intersecting the graph in just one place. So this is the graph of a function. So on this question, we want to determine if a function is even, odd, or neither. The function that we're working with is f of x equals x to the 13th plus x to the 5th. So before we can determine whether this function is even or odd, we really need to know what the definition of that means. So I've got on the side over here a definition of an even function. A function is even if for every x in the domain it fits this pattern, f of x equals f of negative x. Now what these symbols are actually telling us is that the graph of an even function will be symmetric about the y-axis. Now that's not really that helpful in this example because we're not given a graph, we're given the equation. So if we had a graph, we would use the symmetry about the y-axis to decide if the function is even. But we need to use this definition here, f of x is equal to f of negative x. For a function to be odd, we have this definition. A function f is odd if for every x in the domain, negative f of x is equal to f of negative x. And these symbols is a way of telling us that the graph of an odd function will be symmetric about the origin. So what we need to do is we need to figure out if this equation fits this pattern of even function, f of x equals f of negative x, or if it fits this pattern of an odd function, negative f of x equals f of negative x. So I have a process down here that we can go through in order to see which pattern fits. So this is the process. We're going to determine if a function is even or odd algebraically from the equation. So what you notice is that both definitions involve f of negative x. So we are going to calculate f of negative x. And once we calculate it, we're going to take a look to see if that calculation comes out to be the same as the original function, or if that calculation comes out to be the opposite of the original function. So if it comes out to be the same, that is fitting the definition of fitting the definition of an even function. And if it comes out to be the opposite, see this negative here is the opposite, that's fitting the definition of odd. And if it doesn't fit either of those patterns, then we say neither even nor odd. So that's the process that we're going to go through. So we're going to start with our function, f of x equals x to the 13th plus x to the 5th, and we're going to calculate f of negative x. That's negative x to the 13th plus negative x to the 5th. And if you have an odd number of negatives, that means that you're going to have a negative number. So this is going to be negative x to the 13th. And once again, we have an odd number of negatives, and that is negative x to the 5th. So we've done this calculation, f of negative x, and we got negative x to the 13th minus x to the 5th. So if we compare this to the original function that we have right here, I think it's very clear to see that they are not the same. So is it the same as f of x? No. And so we know that it is not an even function. And then we want to see, is it the opposite of f of x? So if we take and we factor out that negative, the negative will be the opposite. We factor out that negative, you can see that this is the opposite of f of x. And so it does fit the pattern of the opposite of f of x, and so it is an odd function. So it does fit that pattern, and we can say that f of x equals x to the 13th plus x to the 5th is an odd function. On this question, we want to use the graph of y equals f of x to answer the question, for what values of x is f of x less than or equal to 0? So what we need to do in this question is really make sure that we remember what these symbols mean. F of x means y. So we want to know when y is less than or equal to 0. So let's focus on the y scale. So we've got our y-axis, Y-axis is the vertical axis. And we know that when we label that scale, we start at the origin here with a 0 on the Y scale. And then we count up. It looks like this one is counting by ones, 1, 2, 3, 4, 5. And then counting down, we have -1, -2, -3, -4, -5. So this is going to help us with what we need on this question, really understanding this, what we call coordinate plane. Sometimes it's called the Cartesian plane, renamed after René Descartes, the mathematician that developed it. So if we understand the scale, we can answer this question. So what we know about the Y scale is that all of the numbers that are above, all of the Y's that are above the x-axis are going to be positive. So let me write that down. We have Y being positive, Y being greater than 0, in what I've highlighted in yellow. And remember, Y is the same thing as f of x. So f of x is greater than 0 on that portion. We know that below the x-axis is where all the Y values are negative. So Y is less than 0. F of x is less than 0. And then right on top of the x-axis, that is when Y equals 0, when f of x equals 0. So remember our question. Our question is, when is f of x less than or equal to 0? When is Y less than or equal to 0? So what we want are the portions of this graph where we have equal to 0 or less than 0. So let me highlight that for you guys in this purple color. So we have an open circle here, and this section here, which is below this point, which is on the x-axis, this point, which is on the x-axis. All of this is below. This point is on, and this point is on. So we want to know the values of x where Y is less than or equal to 0. So the values of x. So I need to write down these x's. This x to this x is below the x-axis, from -12 to -23/2. And then we need to decide whether we're going to use parentheses or brackets. So on this one here, because this is an open circle, that point is not included in this picture. So we need to use parentheses on that one. This point is on the x-axis. That is where Y is equal to 0, so it needs to be included. So I'm going to use a bracket there. Then we have this second section that's below. So I'm talking about this section of the graph that is below. It starts at an x value of -8 and ends at an x value of 1. So we're going to go from -8 to 1. And once again, we need to decide whether we're going to use parentheses or brackets. So we can see that both of these points are on the x-axis where Y equals 0, and that is what we want here. We want when Y is equal to 0. So we're going to use brackets on those. I'll use the union symbol between there. We have one final point. This is an individual point that is on the x-axis. And so that's only one x value of 5. Interval notation is meant for intervals of numbers, so we can't use the parentheses and the brackets on this. So when we're listing a single number or a finite amount of numbers, we use these curly braces to indicate that we're just talking about that one number. So for these x's, -12 to -23/2, union with -8 to 1, union with 5, all of these x values have y's that are less than or equal to 0. Thank you for checking out my videos. Have a great day.